In this video, I'm going to talk about gas reservoirs and the economy of natural gas. You may have thought about these questions. Why is gas cheaper than oil? Why is there no global price for gas as there is for oil? Why is gas production easier? What makes the economy of natural gas challenging? Why is not there OPEC gas out there similar to the OPEC that we have for the oil? In this lecture, I'm going to provide you with enough insight about natural gas reservoirs and its production, so you will be able to answer these questions by the end of this video. Previously, I talked about temperature pressure diagrams and how we can use them in order to design the best possible strategies for optimum production. For the dry and wet gas reservoirs, we learned that their temperature is very high, is above the condensate temperature, which means that the phase is always gas regardless of pressure. So during the production, doesn't matter how much the pressure reduces, the phase is always gas. So because we don't have any phase change, the production doesn't have any complexity. In other words, if we have like phase change, for example, gas becomes liquid or a fraction of gas is liberated from liquid, definitely we have to consider many factors for optimum production. But when we deal with dry and wet gas reservoirs, we don't have such a thing, so the production is much easier. Why is gas production easier than oil? There are several reasons. The first reason, just I mentioned, there is no phase change in dry and wet gas reservoirs, and that makes the production easier. Another reason is the gas viscosity. Compared to oil and water, gas has much lower viscosity, or in other words, higher mobility, and that makes the production easier. Now just let me ask you a question. How does the gas viscosity changes by increasing temperature? So this question is a little bit tricky because in your daily life, you may have experienced that when you warm up honey, it becomes more mobile. So what here, I would like you to think about it a little bit more. What's going to happen to gas if we increase the temperature? Gas viscosity. So the situation is reverse. Unlike liquid, when the temperature and pressure of gas increases, the viscosity of the gas increases because molecules move faster, move closer to each other. There are going to be a lot of collisions, and as a result, gas viscosity decreases by increasing the temperature. Another thing that makes gas production easier is gas compressibility. Compared to water and oil, gas has much higher compressibility. So what is compressibility? Compressibility means the ability of the material to change their volume once they are subjected to change in the pressure. And we know that gas has very high compressibility. For example, if we have a ball that is filled by gas, we know that just if we squeeze the ball a little bit, we can change the volume of the ball. And the reason, because gas has very high compressibility. And this is another factor that helps the production of gas from gas reservoirs. Now just let me ask you a question. Which one is more appealing? A reservoir with high hydrocarbon compressibility or low hydrocarbon compressibility? The answer to this question is very simple. If the compressibility of hydrocarbon is low, it means that the pressure of the reservoir will drop significantly once we start producing hydrocarbon from that reservoir. Okay, so in other words, once we start producing hydrocarbon, the pressure will drop significantly, and we know that the fluid pressure is the major driving factor for us in order to produce hydrocarbon from a reservoir that is 1 or 2 kilometers below the surface. And that's the thing I'm saying, that gas has very high compressibility, it means that the pressure drop for a gas reservoir is not as significant as oil reservoir. Just let me explain it here. So assume that we put a pressure sensor in the reservoir in order to measure the pressure of the reservoir during the production. If we deal with like oil reservoir, the pressure decay will be something like that. And this is time, and this is the pressure of the reservoir. But for gas, it's going to be much smoother. The pressure decay will be much smoother. And as a result, we are able to keep the pressure high for a longer period of time from a gas reservoir. Gas expansion factor is an important terminology when we deal with gas reservoirs. And that is the volume of the gas at the standard condition over the volume of the gas at the reservoir condition. Why this terminology is important? Because the pressure at the reservoir is much higher than the standard pressure. So once we bring gas to the surface facility, its volume will expand. In other words, 1 cubic meter of the gas at the reservoir condition may be expanded to about 100 cubic meter at the surface facility. And indeed, we sell the gas according to the standard temperature and pressure. So when we calculate the volume of the gas in the reservoir, in order to have a better estimate about the revenue that we will make from that reservoir, we have to multiply that volume of the gas by expansion factor, and this is going to be something that we produce at the surface facility. And according to that, we are able to have a more estimate of the revenue that we will make from that reservoir. We are familiar with equation for ideal gas. PV is equal to nRT. Here, P is pressure, V is volume, N is number of moles of gas, R is universal gas constant, and T is temperature. So this equation works for ideal gas, but we know that at the reservoir condition, the pressure is very high. So the gas is not ideal. In order to be able to use that equation, we have to use another factor here that you see here, Z, for the gas that is at the reservoir condition. And Z is a factor that has a range. The minimum value of Z is about 0.27, and for every gas reservoir, the Z value can be calculated easily. So in other words, if we want to use gas equation, we have to consider Z factor here within the equation. So why this equation is important? So previously I mentioned that expansion factor is the volume of the gas at the standard condition over the volume of the gas at the reservoir condition. Here's something that you may notice for the gas at the surface facility. The behavior of the gas is very close to ideal gas. So what I can write here, PS, which means pressure standard, volume standard is equal to NR T standard, a standard condition. So as a result, I can write volume of the gas at a standard condition is given by N R TSC over PSC. So for the reservoir condition, I should be able to write this equation, yes? Yeah. So at the reservoir condition, the volume of the gas is calculated by this equation. So if just I put this value and this value in the equation, you may notice that we can easily calculate the expansion factor with respect to the Z factor, also the temperature and pressure of the reservoir. Here P and T correspond to the temperature and pressure at the reservoir. Z is the Z factor of the reservoir, and as I mentioned, TSC and PSC are standard temperature and pressure. Something that, again, I would like you to pay attention to is that T should be expressed in Rankine if you want to use this equation. So now assume that for a gas reservoir, T is equal to 200 Fahrenheit, P is 2000 psi, Z is 0.9, and considering the standard temperature is 59 Fahrenheit and pressure is 14.5 psi, how much is the gas expansion factor for this reservoir? For this reservoir, the gas expansion factor is 120.5, and the reason that you may have obtained a different number because you didn't convert temperature to Rankine. So this is something that you should mention. This is something that you should always consider. Sometimes gas reservoir engineers like to use gas formation volume factor, and this is the reciprocal of gas expansion factor. So it is not something weird. In other words, if you have the reciprocal of E, it's going to be Bg. So in that case, the volume of the gas at the surface facility or standard condition is the volume of the gas over Bg at the reservoir condition over Bg. Another important terminology is the WAP index, that is the calorific value of the gas, the amount of the energy that is produced by burning a specific volume of the gas over the square root of gamma g. And gamma g is a specific gravity of gas to the air. So in other words, it is equal to the density of the gas over the density of the air. So here you may ask why the WAP index is important. Because the devices that we use in our home or in our factories work within a specific WAP index. So in other words, if we supply those devices with a different WAP index, with a gas with a different WAP index, they're gonna broken after a short period of time. So that's the thing, the WAP index is important. So usually gas producer, they specify the WAP index of their gas before sending to their customer. So in other words, if there is a gas reservoir with higher WAP index, definitely its WAP index should be decreased before transporting the gas to the customers. And how we are able to do that? By mixing the gas with lower WAP index with the gas with higher WAP index, we may reach a specified WAP index. Now you can easily answer to this question why gas production is easier than oil, for several reasons. The first reason is that there is no phase change during production. The phase is gas within wet gas or dry gas reservoir during the production. The second is that gas is highly mobile. Gas viscosity is very low. And the third is the fact that gas is highly compressible. In other words, the pressure drop during production will be very slow. And the fourth reason that I haven't mentioned yet is that the recovery factor for a gas reservoir is very high. So the recovery factor for a gas reservoir is between 50 to 80%. It means that we are able to produce from 50 to 80% of gas within the reservoir from a production. Just comparatively, for oil, the recovery factor can be as low as just 5%. But what about the gas economy? The gas economy is a little bit more complex compared to oil. The first thing is that transportation. Gas transportation is very difficult. Definitely, we should have a network of pipeline in order to transport the gas to customers. So if there is no network, we have to build it, and that costs money. So in other words, assume that you have a reservoir and there is no network, so you have to build a network and also spend some money for the maintenance over the time. And that's the thing, a gas reservoir becomes profitable if it has enough gas to supply that network at least for 10 years. So that's the thing, when we are looking for a gas reservoir, we have to make sure that the gas reservoir is big enough so the revenue that we make from that reservoir will cover the production cost and also the network cost as well. Another question that you may have thought of is that why gas is much cheaper than oil. Definitely one reason is the transportation. Gas transportation is much more difficult than oil. Another may be the storage. Gas storage is more difficult than oil. But the main reason is the calorific value. In other words, if we burn 1 barrel of the oil, the energy that is produced is equivalent of about 1,000 barrels of gas. So we have to burn 1,000 barrel of gas to produce the energy that is released from burning 1 barrel of oil. So that's another reason that you may think why gas is much cheaper than oil. Another thing that, again, related to gas transportation, so it means that the market for gas is local. There should be some network. We are not able to transport the gas to some location that is far away from the reservoir. And again, that's something that dictates the economy and also gas price. Indeed, unlike the oil, that there is a global market, there is a global price for the oil. For the gas, the price is so local, and that depends on the contract between the provider and customer. Okay. For example, assume that you're in an area that there is a lot of natural gas and the climate is very hot. So the demand of the gas is not very high. At the other hand, the gas supply is very high. So in that area, the gas will be very cheap. On the other hand, if we are in an area that gas is rare and the climate is so cold, in other words, we have high demand with low production. In such a case, we should expect that within that area, the gas price is very high. So that's the thing, that there is no global market for gas. So gas price is determined between the contract between the provider and customer. If we look at any reservoir, the production stage can be divided into 3 stages. The first stage is the build-up stage, in which we build up the production facility. And what you see here, once we develop more facilities, the production rate from that reservoir will increase over the time till reaching a plateau that is the maximum production that we have. And after a period of time, because of the pressure drop in the reservoir and other factors, we see a decline in the hydrocarbon production. So it doesn't matter if we deal with a gas reservoir or we deal with an oil reservoir, we always have these three production stages. Now just let's look at the production stage, gas versus oil. As you see here, because gas has very high compressibility, usually the plateau stage. Now just let's compare the production of gas versus oil. As you see here, the plateau period for gas is much longer compared to oil. And the reason, because gas has very high compressibility, higher recovery factor, and that's the reason the plateau period is much longer compared to oil. But I mentioned that the calorific value of the oil is much higher than gas. So in terms of the energy that we produce, or maybe the revenue that we may make from an oil reservoir, in a short period of time, we may produce much higher energy compared to a gas reservoir that we produce over a much longer period of time. And that's something that makes gas different from oil reservoir. In other words, we can produce a lot of energy from a gas reservoir for a very long period of time. At the same time, we can produce a lot of energy from an oil reservoir, but for a shorter period of time. And that's something that dictates the economy of an oil reservoir. In other words, for a gas reservoir to become profitable, it should be very big, it should be huge. But for an oil reservoir, even though it may be very small compared to a gas reservoir, it may be still profitable. Another thing that is important when we produce gas is wells. We should drill so many production wells over a reservoir so to be able to meet the demand during high seasons. For example, during winter time when the demand goes very up, we should produce a lot of gas. So that's the thing, when we have a gas reservoir, the more production wells that we have, we are able to meet the demand during high season. What you see here shows like a schematic of a gas reservoir. Yellow means the gas zone, and the blue is the aquifer or water. So as you see here, we should drill so many wells, and the location of the well should be close to the apex of the reservoir, away from the aquifer, because we don't want to produce water during production. As low as water that we can produce, we should do it. We should minimize water production, and in order to do so, these wells should be close to the apex of the reservoir, away from the aquifer. And that's the major thing that we should consider when we drill a well for production. I hope that you have enjoyed the lecture, and through this lecture now you should be able to answer some questions such as why gas production is easier than oil, why gas is cheaper than oil, and why selling gas is more challenging than oil. Thank you very much for your attention.